Okay? And you guys got to remind me, because sometimes I pause it, and then I start it again. You guys got to remind me, okay, when we do it. Okay, so looking at these lines right here. Okay, let's start with L. Who did L? Who would like to volunteer to tell us about L? What is the slope of L? Oh, average rate of change, right? What is average rate of change? What's another name for it? Slope. Everybody write down up there where it says average rate of change, write slope. Okay? Actually, average rate of change is for the slope of a certain point on a curve, whereas just rate of change is slope. Okay, so who thinks they got M? Come on. Need a brave volunteer. Come on. I had half the other class know it. I know I got someone in here knows it. Well, I'm not saying that, but you're starting to make me think it. So what did you get? So you didn't count the slope? You guys, rise over run. Do you remember rise over run? What is it? 1 over 1 for M? Yeah, look, right here, you guys. I can go up 1 and over 1, right? Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay? 1 over 1 equals 1. The slope of M is 1. Do you remember didn't we talk about rise over run last time? Did I miss something in this class? Did we talk about rise over run? Okay, that's the slope. You guys are starting to make me think I didn't teach this right last time. Okay. Well, let's start with L first. What about L? Who thinks they've got that one? Alex? 1 over 4. What do you guys think? Negative 1 over 4. What do you guys think? Because it's going down left to right. Yeah, you guys, this is 1 over 4. Look. Down 1, 1, 2, 3, 4. I'm back on line. Down 1, 1, 2, 3, 4. I'm back on line. Down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. Now, whenever I go down, I say negative. Go to the right, say positive. If I go left, I say negative as well. So this is a slope of negative 1/4. How many of you had that?
I actually just got that one.
Okay, good. All right, let's go to N. Huh? That's the answer. We're just looking for the slope. How steep is this thing? Remember I got out the board the other day? Leaned it up against, wasn't that in here? Did I miss that in here? Okay. Okay. We found how steep something is, right? That's slope. What about this? Why is it undefined? Yeah. If I choose 2 points on there, this is 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3, 6, 3, and 6, 5, right? What happens if I use that slope formula? 5 minus 3 over 6 minus 6, which is 2 over 0. And we decided that you can't divide by 0, right? So we say it has no slope because it's undefined right here, right? No slope. So is that, someone asked a question. Does that mean that's undefined? Okay, right. So right here, let's say I chose this point and this point. 1, 2, 3, 4, down 4, and to the left 1, so left 2, negative 4, negative 2, and 1, negative 4. Okay? 1, negative 4. Say that again. Man, thank you. I'm really going to confuse some people in here. And 1, negative 4. All right. Okay. So, so we have that. So if I figure out the slope on this one, negative 4 minus a negative 4 over negative 2 minus 1. What's negative 4 minus a negative 4? It's 0, isn't it? And negative 2 minus 1 is negative 3. What happens when you divide a number into 0? 0. So we call this one has 0 slope. It's horizontal line. All horizontal lines have zero slope. All vertical lines have undefined or no slope. Okay? Remember that? Okay, so everybody get out your assignment from last time. Average rate of change. Average rate of change, all it is finding the slope. We use the formula slope equals y2 minus y1 over x2 minus x1. And we plugged numbers in and we found the slope. Any questions there? Okay, so we went over every single problem except for what? Which ones? The 4 on the back and what else? Oh, there's a couple of them. Yeah, there's a couple I skipped, right? Were there any questions on any problems you want to ask about? Number 2 on the back? Okay, what was the question on number 2 on the back? We had this. We had something like this, right? And we had 1 hour, 2 hour, 3 hours, and then we had what? 25, 50, and 75. That was a distance in miles, right? And we found out that, and number 2 asks, what question did number 2 ask? Between the first 2 hours? So between where and where along the x-axis? Between 0 and 2 or 1 and 2? 0 and 2. So I'm going between 0 and 2. What, at 0 right here, what's the y coordinate? So we have one of our points is 0, 0. At 2, what was it? If you look at that carefully, doesn't it look like it's about 45? It's just a little bit. Here's a 50 line, and here's the 2 line, and it was just a little bit below that, right? About a fifth the way down between 50 and 25 right here. And so I don't know. I think that we're just estimating, but I would say 2, 45. Would you guys all agree with that? Okay, Saren, using that formula right here. y2 minus y1. What's y2 and what's y1? Okay. Okay. So we can do it that way. We can go 0 minus 45. Or we could do 45 minus 0, either way. But since I went 0 minus 45, what do I have to do on the bottom, Saren? What do I have to put on the bottom? What's x2 and x1? Okay, so 0 minus 2, and I get negative 45 over negative 2. If you did 45 minus 0 and 2 minus 0, which you can do that too, then you're going to get positive 45 over positive 2. But what's a negative over a negative, you guys? Positive, so it didn't really matter. We made it positive anyway. What's 45 divided by 2, everybody? 22.5. How many of you guys got that? So what does 22 and a half represent in the context of this problem? Say that again. Miles. Miles that they, okay, and let's redefine that. That's how many miles they went? Because how many miles did they go? They went 45. So what does this 22.5 represent? Average miles, right? Per hour. Does that make sense? They averaged 22.5 miles an hour. They were moving. I guess it depends on what they were on. They're on bikes. That's moving for bikes, isn't it? Pedal bikes. If you had to go 50 miles, 45 miles, that's pretty good pace, isn't it? 22.5 miles. Saren, your dad's a biker. What do you think? You've never been biking with him? Did you have a speedometer on your thing? Did you know how fast you were going? All right. We'll ask him if 22.5 miles is a fast pace on bikes. So, huh? I would think that's a pretty fast pace, but I don't know for sure. Okay. Any other questions? You guys got all of them done? What'd you get for number 1? 25. How many of you got 25? What'd you get for number 3? Huh? 21. How many of you got that for 3? 21. What was that one between? Between what and what? 1 and 2. Okay. 1 and 2 hours. I would have gotten 25, no, 20 miles, but 21, yeah, that makes sense too. Okay. As long as you're somewhere around 20 or 21, somewhere around in there. What about number 4? Huh? 30? How many of you got 30 for that one? Okay, what was it between? 2 and 3. Yeah, because it was what? We guessed it was about 45 to 75, which is 30 miles, right? Okay. All right. Everybody, turn in your assignment. Okay, so one thing you need to know right now is every function is a relation. And we'll talk about that more in just a little bit. Every function is a relation. But not all relations are functions. We're going to talk about which ones are functions, which ones are not today. So by the end of the day, I want you guys to know what the difference is between a relation and a function. Okay? All right, an example of a relation would be something like if this is x and this is y. Let's say I had 2, 3, 8, and 10 for x, and I had 1, -7, 5, and 4 for y. Okay? That is an example of a relation. We could graph that. I could plot the point 2, comma 1, and the point 3, comma -7, and the point 8, comma 5, and the point 10, comma 4. That right there is a relation, okay? Some of these numbers are domain numbers, and some of them are range. Do you guys know which ones are which? Other way around. Yeah, domain is the x numbers. Or if it's a function, it's the independent variable or quantity. Range is the y numbers. I should say values instead of numbers. And if it's a function, it's the dependent. Do you remember the other day when we had that assignment on, what was it on? It was on those graphs where we had to draw those graphs, and I had sketching the graphs, that's what it was. And I had a definition of function at the top. It says function tells how one variable quantity depends on another variable quantity. Do you remember that? And all functions are relationships, so it was relating to variables, right? Okay, so this is a relation. Now, it's not a function, and I'll tell you, I mean, this is a function as well, and I'll show you why in just a little bit. But we're going to write this down right here. There are 4 ways to represent a relation, and I want you guys, actually there's 5 ways. So we're going to go 5. I'm going to add one down at the bottom right here. Okay, 5 ways to represent a function. So I want you guys to think about some of the ways we've already represented functions in class, or a relation. This whatever I say about relations applies to functions, since most of that I mean, every function is a relation. Okay. Good. Equation is 1. I write that down. Equation. Equation is 1. I'm going to write write an example of equation right there. That's one way. What was that? Would that represent two variable quantities being represented in each other? Okay. What's another way? Come on. We've done some. A graph. Good. Was that you, Rhett? Okay, a graph is another way. Okay. If I graphed this line, right, this function up here, this relation, I would go up to 3 because that's the y-intercept, and then I'd go up 2 and over 1 for the slope, up 2 over 1, and I would put this line right here through them. And that would be a graph. So a graph is a second way to represent a function. Can you think of another way? Okay, now the vertical line test is a way to test to see if a relation is a function, but it doesn't represent a function. And we're going to talk about that in just a second, so that's good. Okay. Come on. One more way. You guys got to think of at least one more way. Yeah, right there. A table. He called it a T-chart. A table is another way. For example, right here. Right at the first thing right here. Isn't that what we just did? We represented a function as a table. Okay. So right here, let's take the same function or the same relation right here. What if I put 1 in for x? What do I get for y, you guys? No. No. If I put 1 into this for x, I get 5. How did we get that? 2 times 1 is 2 plus 3 makes 5. So if I put 1 in for x and simplify that, I get 5 for y. Okay, what's another? Let's say negative 2. Let's say I put negative 2 in. 2 times negative 2 is negative 4, plus 3 is negative 1. What if I put 0 in? Nope. 3, because 2 times 0 is 0, plus 3 is 3. Let's say I put 5 in. 13. Okay, so we can represent a relation with a table. Anybody want to try and think of the other two, or one more of the other two? Okay. And draw lines to them? Yeah, like it was like. If I connected all these, if I put these? Actually, we have this one already up here. Are you saying graph them? No, it's like he was talking about. Oh, a mapping like this? Yeah. Oh, so you got 1, negative 2, 0, and 5. And 5, negative 1, 3, and 13. You know what? I should add this one. Okay? So that's called a mapping. And you can, well, it's more of a way of representing the domain and range rather than the relation, but it kind of does. I can see how you get that from that one. Huh? Maybe not list that one right now because we got 2 others. Any other ideas? Okay, the other 2 are these 2 right here. Ordered pairs. Ordered pairs would be almost the same thing as a table. Okay, but ordered pairs, I would write like this. 1, 5, negative 2, 1. 0, 3. 5, 13. Here's the difference, though. Okay, let me ask you guys this. For this equation we wrote up here, is this all the points that equation can generate? many are there? How many points could we put on this table? As many as we want. So how many are there? Infinitely many, right? Because I can choose any x number, and I'll get another y number for it, right? And how many numbers are there? Infinite number of numbers, right? And so this is not a complete list for my table. This is just a sampling to help me get an idea of what the graph would look like if I graphed it. Whereas when we do ordered pairs, usually it's a finite set of numbers, and it's just points that we graph. And there's two types of functions we're going to talk about in a little bit, but not yet. Continuous and discrete. Continuous is a graph where you can trace it without lifting your pencils. And a discrete is a bunch of points, okay? A bunch of dots. Okay, the last one is a word problem. This is another way to represent a function or a relation. For example, I'm going to use this equation up here. Y equals 2x plus 3. I'm going to say there's a car company. They rent cars for $3 plus $3 plus, what was the equation? 2. So plus $2 per mile. Is that an expensive plan? Would that be a lot of money to rent a car? Depends on how far you're going, right? If you were going just a little ways, is it bad? Yeah, it's pretty good rental agreement, right? If you're going a long ways, is it kind of bad? $2 a mile is pretty expensive, right? Okay, so it depends on how far you're going. But this is an example of a word problem, and it represents that equation up there. So there's 5 ways to represent a function. Plus, this mapping is kind of one, too. Yeah, you could almost put mapping on there. You could almost add a 6th one right there, okay? All right. Now, go to this one right here. How many of you guys remember what domain and range are? Oh, we just talked about it. So, who thinks they know what the domain of this function is? I want everybody right now to talk with your shoulder partner. Jack, you're going to talk to these 2 behind you. Everybody talk to your shoulder partner. You got 30 seconds to decide what the domain and range of this number 1 right here is. What's the domain and range? Given that graph. Just talk about what you know about it. Go. Who thinks they know what the domain of that one is? What? It's the x-axis. What do you mean by that? So you're saying just wherever it crosses the x-axis is the domain? No, you're on the right track. Go. Now keep in mind, domain is their numbers, right? What numbers could this function, what x numbers could this function be? I'm probably confusing you, but what? It never stops. So what is the domain? Infinite numbers. What's a way we can explain all numbers on a number line? What's the word we use? There's a word. Who said that? Right there. All real numbers. That's it right there. Everybody. The domain is all real numbers. Because, look, you guys, it doesn't matter what x number I choose. Let's say I chose this x number right here. It's a negative x number, right? Could I go up and down and hit the graph somewhere? If I went down, I would hit the graph down here somewhere, right? So that x number works. What if I chose an x number over here? Because it has a corresponding y number right up there, right? So any x number I choose is going to be along this thing. In fact, this thing has an arrow on it. What do the arrows mean on the ends of them? They go forever. It doesn't matter what x number I choose, it's going to have a corresponding y number. In other words, the domain, you guys, is all the x numbers. It's how far it goes left and right. How far does this thing go left and right? Forever, both directions, right? And so we would say that the domain is all real numbers. Another way some of your books write it is they have this R like this. Have you guys ever seen that in books, textbooks? That R, that means all real numbers. Another way sometimes books write it is like this. Negative infinity to infinity. That means it goes on forever in both directions, right? Okay? So that is the domain. Because this thing goes left and right forever. Now the range is how far it goes up and down. What do you guys think the range is? The range is all real numbers. It goes up and down forever. This thing is going down and to the left forever. It's going up and to the right forever. The domain and range are both all real numbers. Every number is going to work. Okay, now, let's see if you guys learned anything from that. Go to this problem right here. I'm going to give you 1 minute to discuss with your partner what the domain and range of this is. Go. Okay, let me have your attention back up here now. I am going to pick on a couple of groups right here. I'm going to start with this group right here in the back, you four. Tell me what the domain of this function you think it is. You two, do these two think it's different? Okay, let's go to another group. Let's go to this group. What do you guys think the domain is? Wait. Don't tell me the range yet. You guys think the domain is all real? What do the rest of you guys think? Anybody disagree? How many agree with it that it's all real? Okay. The fact of the matter is, how far does this thing go to the left? Forever. How far does it go to the right? Are there any gaps in between where you have to lift your pencil? So any x number you choose is going to have a corresponding y number. So if I choose an x number here, it's going to have a y number. I choose an x number out here, it's going to have a y number up there somewhere, right? An x number out here, it's going to have a y number up there. It doesn't matter which x number I choose, it's going to be a corresponding y number. So the answer is all real numbers, okay? So the domain, all reals. Sometimes I just abbreviate it like this. All reals. Okay, I'm going to pick on this group right over here to tell us the range. What do you guys think the range is? Huh? Okay, Brock says all above a certain number. Can you tell what that certain number is? Anybody else think they know what that certain number is? How about you guys over here? What do you guys think it is? Greater than or equal to 0. What do you guys think? Is that correct? Yeah, that is exactly right, you guys. The range is all numbers. The range is all real numbers where y, what happened to my, it's wigging out. Just a second. Where y is greater than or equal to 0. Why is it y is greater than or equal to 0? Yeah, see, what's the lowest point on this graph, Stella is saying, is at the y value is 0, isn't it, at that point? And every point is above it, right? You guys understand what I'm saying? No part of the graph exists down here. You can't find any part of the graph that exists for the range below the x-axis. Nothing exists down there. The graph only exists above the x-axis. Okay? Good job. Okay, so we're going to talk more about domain actually next class. But right here, we're going to talk about a function now. We've talked about functions already, but we're going to see how they're different from a relation. Okay, it is a relation in which each element of the domain is paired with exactly one element in the range. I'll give you some examples of this in a second. Go ahead and write it down. Okay, so here is a function. I'm going to do this. I'm going to draw another one over here. I'm going to have to do some additional ones, but let's say I do this. That right there is a function. Why is it a function? Well, actually, the dots don't keep going. This is the whole function. You see it. It's a finite function. We have a special name for a function like this. When it's just points, it's called discrete. You might want to write that down. When it's just a bunch of points, we call it discrete function. Okay? You'll notice I'm going to list these as a table. I'm going to list the graph as a table. It's -3, comma 1, -2, comma -2, -1, comma 0, 0, comma 1. I'm going to continue this over here. 1, comma 3, 2, comma 2, and 3, comma -3. Okay? Now, if you'll notice, do you see any x numbers listed more than once? They're all listed once. That's what it means. Each thing in the domain is paired with exactly one. Everybody, this is the key right here. Exactly one element in the range. Okay? Every x number is only listed once. Okay, here's another function. That right there is also a function. Why is that one a function? Where every x number, there's only one y number. This is a quick way of doing it called the vertical line test, you guys. If you can draw a vertical line anywhere on the graph and it only crosses one time or less, then it is a function. Because I'll show you why. I'll show you a one that's not a function a little bit. See this one? That dot, all these dots, none of them, I mean, every vertical line can only pass through one point, right? Every vertical line only passes through one point. So, everybody write down, the vertical line test determines a function somehow. Write this down. If a vertical line only goes through a graph once or less, then it is a function. If a vertical line goes through a graph one time or less, then it is a function. By the way, this kind of function is called a continuous function. Because it's smooth, you can trace it with a pencil or pen. Okay, now I'm going to show you some more examples here. Just a second. You guys still writing down, or are we good? Anybody still need time? All right. I'm going to write down a bunch of graphs right here. And you guys are going to tell me which of these are relations and which of these relations are functions, which are just each, okay? I want you to discuss it with your partner. Don't say it out loud. Just discuss it with your partner. Say it out loud to your partner, okay? Whether yes or no on each one of them. Okay, here we go. Okay. Yes or no on all of them? Okay, here we go. I'm going to start with you two. Number 1, yes or no? Yes. Why? Because it passes the vertical line test, right? Every line goes through it only once. Okay. Number 2, Jack. No, why not? Vertical line would touch twice, right? Okay. You two. Vifnu and Dalara. What? Yes? Okay. Every vertical line touches once, right? Like this one? What do you think? What is this one? It's not, because look, vertical line hits it more than once. Well, straight up and down, even a vertical line, like when we did the bell work today, that vertical line, any vertical line is not a function, because if you drew a vertical line through that vertical line, it touches at every single point, right? More than once. So no vertical line is ever going to be a function. It could, if it just slopes just a slight bit, then it's a function. Okay. How about this one? Alex. Yes. Who's with Alex? Tell me your name again. Megan. Okay. So that one is. Okay. This one's not. This one. Okay. This one's not either. No. Okay. No. No. Yes. I got to write this down for someone watching at home. Yes. No. Yes. So you get them all right? Okay. Discrete or continuous? Okay, continuous. Discrete or continuous? Discrete. Discrete's a bunch of points. So this one right down here is discrete. Okay? All right. Function notation. How many of you guys know what function notation is? Okay, function notation is when we use an f of x. Let's say I have f of x equals x squared minus 3. Okay? X squared minus 3. If a relation is a function, we can replace y with f of x, or g of x, or h of x, or j of x, whatever you want to call it. Okay? We give it a name. So one of the things that's nice about function notation is you can come up with different names for a function. F, G, H, whatever. Okay, if you just leave it as y all the time, it's the same thing. But you guys need to know this. F of x and y are the same thing. You might want to write that down. F of x and y are the same thing. So it's just it's the y variable. It's the independent variable, right, on a function. Or the dependent variable on a function. Dependent variable right here. Okay. This is how we use it. We use it so that we can plug numbers in. Everybody knows what in fact, let's do this. Everybody, with your partner, I want you to find f of negative 4 for the function f right up here. Okay, with your partner, check to see if you got it right. F of negative 4, go. Forgot to turn this on, so. Okay, we found f of negative 4 is 13 by plugging negative 4 into the function f. Now we're finding g of 9 for the new function. It's right up here. G of 9. Make sure you use function g and not function f. Okay. Okay, what'd you guys get? 110. How many of you guys got 110? Okay, because this just means 12 times 9 plus 2. So 12 times 9 is 108 plus 2 makes 110. Okay. We got to find h of a. Here's function h right here. I'm going to write a different color. Function h of x equals 3x minus 4. Everybody find h of a. This is a tough one. 3x minus 4. Raise your hand if you got it. Okay, anybody else? What? You guys don't have it yet? Jack, tell them everybody what it is. 3a minus 4. Why 3a minus 4, Jack? Exactly. Go ahead, McKay. Huh? Do you need anything? Oh, you need the assignment. Write it down before you go. Everybody write it down right now. Hey, this looks like a long assignment because it is. Okay. All right. So that is a different class. Did I give that to you? I was probably thinking you're a different class. That's a different class. Okay. This is your homework assignment. Now, let me tell you how I'm going to do it if I haven't told you yet. Today's Thursday, right? I expect you to try all these problems, and then on Monday, ask me the ones you're having trouble with, or if you just don't know how to do certain sets of problems on there. I will go over those problems, and then this assignment will be due on Wednesday. So you got 6 days to do this assignment, okay? So it might look long. Do it. You guys, if you wait till Tuesday to do this assignment, you're going to probably be lost. If you come to class Monday without having tried it, it probably won't do you much good when I go over it. It's important that you try every problem before you come to class. You'll be a lot more successful if you do it that way. We'll turn in the assignment next Wednesday, okay? Go ahead. Okay. All right. Here we go. I'm going to go back here. Say that again. We're going to do the last one. Yeah. J of C minus 5. What does that mean? Should I write a function J? Here's function J right here. J of x equals x minus 2. Okay? X minus 2. So what is this going to be, you guys? What am I going to do? I'm going to go C minus 5 minus 2, right? C minus 7. Minus negative 5 minus 2 is negative 7. That is not for your class. Yeah, probably. Okay. All right, guess what? That's all I have. Okay, go ahead and work on your assignment.